Hello calculus students, welcome to video 3e. Today we're going to discuss the derivative of sine of x and cosine of x. Here we see the graph of sine of x. Remember, it's a periodic function. The basic function repeats every 2 pi radians. We're going to find its derivative. So to begin with, I want to start by thinking about what the derivative should be. So here's the graph of sine of x, actually 2 periods of sine of x. And we see right here, there's a horizontal tangent. So at that point, the derivative should be 0. So I'm going to mark a 0 right here on that curve. I'm going to try to sketch the derivative. Right here, this slope is about -1. That's kind of hard for me to draw that right there. But that slope is about -1. That occurs at negative pi. That's right there. This is 0 right here. That's at pi over 4. That would be right there. Then this slope right here, that tangent line has slope about 1. So the derivative would be right there. Right here, the tangent is 0. So I'm going to plot 0 there. Again, I'm trying to sketch the derivative. All right, I forgot this point right here, back here, that slope is 1, so that would be right there. Okay, and then at pi, the slope is back to being -1, so we'd have a point there. And then right here, the slope would be 0, so the derivative would be 0 there. And right here, the slope is about 1 again. So it would be here. So I'm going to do my best with my pen here to sketch what we get. So this part kind of comes down like this. And this part comes down like this. Oh, it's very wobbly, but what we get is a graph that looks kind of like sine. Okay, but it doesn't go through 0 here. This is actually the graph of cosine. So since sine is kind of repeating and going up and down like that, actually its derivative kind of does the same thing. So cosine starts at 1 when the angle is 0, and it goes through its cycle like this. Okay, sine starts at 0 and then goes through its cycle. So we think that the derivative of sine might be cosine. So our guess is that the derivative of sine of x is cosine of x. And indeed it is. And we're going to prove it. So the way we prove it is we go back to the definition. So, all right. So if we assume that f of x equals sine of x, and here we go. F prime of x would equal the limit as delta x goes to 0. It's been a little while since we've done this. Of sine of x plus delta minus sine of x all over delta x. So remember, the formula for derivative is f of x plus delta x minus f of x over delta x. Instead of f, we have sine. Now, I'm going to need this little guy down here. This is from your pre-calc days. This is the sum of angles formula. And it's going to help me break up this expression with sine of x. So here we go. I got limit, delta x goes to 0. In the formula down there, x plays the role of a, and delta x the role of b. A plus b, x plus delta x. So all I got to do is plug in x and delta x for a and b. All right, so it's sine of a, that would be sine of x, times cosine of b, so cosine delta x. All right, plus cosine of a, that'd be cosine of x. Sine of b would be sine of delta x. All of that was expanding this first thing here. Then we have minus sine of x all over delta x. Okay, I'm going to factor something out here. I'm going to factor out a sine of x out of this term and that term. So I'm just going to do a little rearranging. So this is the limit. As delta x goes to 0, I'm going to put this term first. Is cosine x, sine delta x. So I wrote that term. Then I'm going to factor out a sine of x out of these two terms. So I have cosine delta x, and then minus 1. So I factored a sine of x out of that term and that term. So everything's accounted for here, all over delta x. Okay. Actually, believe it or not, we're making some progress here. So I'm going to break it up a little bit more. This is the limit. As delta x goes to 0, I'm going to put this part here first. Cosine x, sine of delta x over delta x, plus, this is all in the limit. Well, I can break it up into two limits. The limit of this plus the limit of that. So I'm going to go ahead and do that. I didn't mean to, but it's okay. Then I have this part, sine of x. And then I have cosine delta x minus 1 all over delta x. Okay, wow. So what did I do? I really kind of broke it up right there. Okay, and wrote this part, the limit of this part, plus the limit of that part. Okay, now, we got to recall a couple facts. Sine of delta x over delta x, that was a special limit and was on our last quiz. That approaches 1. So this limit approaches cosine x times 1. There's no delta x in this right here. So as delta x goes to 0, cosine x is not even affected. It's just cosine x. Sine of delta x over delta x, as delta x goes to 0, this goes to 1. We talked about that when we talked about the squeeze theorem. Plus, okay, limit of delta x goes to 0 of sine of x. That's all cool. This was another special limit we talked about. It wasn't on the quiz, but we talked about it with the squeeze theorem. And it approaches 0. So we get that the derivative is equal to cosine of x times 1 plus sine of x times 0, which is, voila, just cosine x. Ah, math is beautiful. So we get that the derivative of sine of x is cosine of x. Now, proving it, kind of complicated, all right? Involve these kind of special limits we talked about with the squeeze theorem. But to be honest, all we're going to care about is knowing this rule, that the derivative of sine of x is cosine of x. Okay, so I'm going to present two rules. So with that aside, this is actually not going to be so bad because using these rules is easy. The derivative of sine of x is cosine of x. We just discussed that. And here's kind of a matching rule we're not going to prove. We want to find the derivative of cosine of x. Well, it'd be nice if it were just sine of x, but the derivative of cosine is minus sine of x. Alright, so these two derivative rules are going to come up again and again and again. So we got to remember, the derivative of sine is cosine. The derivative of cosine is minus the sine. Alright, the rest of the way is going to be really kind of easy here. I'm just going to kind of practice using this. So now this is kind of the same thing we have been doing, finding derivatives of sums of terms. But now sometimes they have a cosine or a sine in them. Now this will be okay. So if I want to find the derivative here, y prime, well, this is old news. This is 5 times the power of x. So it's going to be 2 times 5x. Or here, let me write it the way I always had. So 5 times the derivative of x squared will be 5 times 2 of x. And then here we have 3 times the derivative of cosine of x. And this is a step that's okay to skip as long as you get the right answer. So I'm just kind of showing all my work. So we get y prime is 10x. That's what I was about to do. 2 times 5 is 10. X to the 1 less power is x. Plus, here's the new guy, but that wasn't so bad. 3 cosine of x. Alright, so hopefully if your pulse was racing during the proof of the theorem, Hopefully it's calmed down a little bit. Actually, using the rules is no problem. But it's good to see where they come from. So let's do this one. So we get y prime equals. Pi over 2 is just a constant. It's pi over 2 times the derivative of cosine of x, which is minus sine x. So altogether we get minus pi over 2 sine of x. Done. All right, on this one, y equals 4, or y prime equals 4 times the derivative of x would be 4 times 1, plus 2 times the derivative of sine of x, which is cosine of x, which would just give me 4 plus 2 cosine x. All right, very last one. 2 trig terms. Both of them, no problem. Y prime is going to be 6 times the derivative of cosine, which is minus sine of x, minus 2 times the derivative of sine, which is cosine of x. All right, if I clean it up a little bit, I get minus 6 sine of x, and then minus 2 cosine of x. Done. That's the derivative. So now we can do terms with sine and cosine of x. Okay, so here's your journal assignment. Find the derivative of these 3 functions. Okay, good luck.